Hi guys, welcome back to the next video in the series of videos about Chapter 5 Forces and Motion. In the previous two videos we talked about the acceleration, and if you've not yet seen those two videos, I suggest you do that now, and you can use the links that pop up now. Okay, in today's video I will explain what causes an object's motion to change. Like before, let's review today's learning goals. After this lesson, you will be able to explain what the resultant force is, determine the magnitude or size and direction of the resultant force by adding all the forces acting on a single object, and explain what happens to the speed of an object on which a resultant force is acting. But what is a resultant force, and how do you figure out its magnitude and direction? Let's have a look at an example. When you're cycling, your muscles provide the driving force. This driving force is needed to keep you moving forwards. At the same time, there are forces acting against you, or rather, against your motion. Air friction and rolling friction are trying to slow you down. Air friction and rolling friction are two examples of so-called resistance forces. This figure shows a cyclist with four forces acting on him: the gravitational force Fg, the normal force Fn, the driving force Fp, and the resistance force Fr. It is clear from the figure that the normal force and the gravitational force are acting in opposing direction, upwards and downwards, and are both the same size. That means they cancel each other out. That means that only the driving force Fp and the resistance force Fr play a role when determining the resultant force. Since the gravitational force and the normal force cancel each other out, we don't need them any longer in this figure. Actually, we can clean up this figure even more. We're not interested at all in what the cyclist and the cycle look like, at least not from a physics point of view. We're only interested in the forces acting on the cyclist. A so-called force diagram shows us all the details we need. There you go. This is a force diagram showing us the two forces that are relevant for the resultant force. The resultant force is the net result of all forces acting on an object. In other words, it's the sum of all those forces. In this case, it is the sum of the driving force and the resistance force. However, the driving force is pointed to the right, while the resistance force is pointed to the left. And that means that the resulting force is equal to the driving force minus the resistance force. And this is the resultant force. It is smaller than the driving force, but it is also pointed to the right. You may wonder, what's so special about the resultant force? The answer: the resultant force can tell us what will happen to the motion of an object. When the driving force is larger than the resistance force, the object will accelerate. When the driving force is smaller than the resistance force, the object will decelerate. And when the driving force is equal to, but in opposite direction to the resistance force, the object's speed will not change. Concluding, you now know how to explain what we mean by the resultant force, determine the magnitude and direction of the resultant force, and explain what happens to an object's speed based on the resultant force. And that brings us to the end of this video. Next time we will look in more detail at the relationship between the resultant force and acceleration. Until next time.